Recording in progress.
Okay, so today we are starting a new topic and a new subject, which is basically introduction to AI or artificial intelligence, right? And we are going to start with the very basics, that where from this concept of artificial intelligence came in, and what are the different branches, and where can we go from there? What is the basic artificial intelligence algorithms? What do we need in order to go, and do some work on artificial intelligence field? Okay, so let's start. Okay, so artificial intelligence is basically uh, I would say it's a technology where the system or the machine is supposed to behave or mimic human intelligence uh, to perform certain tasks, and it can iteratively improve the performance of the task based on the data. So basically, artificial intelligence is what? It is a technology which mimics human behavior. And with can you hear me? Hello?
Yes, one.
Okay. Okay. So with this, one other thing that comes into our action is that when we are performing certain task which is mimicking human behavior, artificial intelligence systems are also expected to improve over time the performance based on data. Okay. This is basically what we basically say as artificial intelligence is. So there are certain characteristics of artificial intelligence which makes this such a coveted and such a hot technology, right? So there is the first characteristics is that it has problem solving capabilities. The second characteristics of artificial intelligence is that it can adapt to new situation. And then it has the capacity to work with complex and works with complex and ambiguous information. Okay. So the thing that to understand over here is in a traditional computer program, if this is a machine which has a computer program running. So what happens is that we give in some input and we expect an output. And this is a some code that is running over here, right? This is a traditional computer program. The thing with artificial intelligence is that we there is some algo that is running that has learning capabilities, which means that we feed into the algorithm. Sorry, let me delete this. Okay, so we feed into the algorithm both the input plus the output. Then we expect this particular algo to train, and then the output that we are expecting is nothing but some pattern and pattern based recommendation. You can say that this is a behavior of a recommended system, but it is in general that I'm just saying. So this is the difference between a classical computer programming approach and then the artificial intelligent algorithms. Any question till now?
Yeah, looks okay. Go ahead.
Okay. So here, what we have to understand is that when we are thinking of this as a system or a machine, this machine runs an algorithm, right? This machine runs an algorithm. Now, this algorithm is fed with some input and output data. You are feeding the both input and output data. So this is where it is trying to train and it is trying to come up with some pattern. And with that pattern, it can actually go out and do any kind of prediction, newer prediction. Okay. Actually, this is not recommendation. This will be prediction. Anyways, so let's understand from a very basic point of view. We have an equation which is like 2x plus, sorry, let's not go into the equation. Let's go in directly into some value-based understanding. So we have three numbers, which is 2, 1, and 5. Now, the way that these numbers can be related is basically if this is x, this is y, and this is z, we can write 2x plus y equals to z. This can be a formed equation, correct?
Mhm.
So in this case, what happens is that when this kind of equation is being fed, this equation can be rewritten in this form, right? W1x plus W2y equals to z, wherein W1 equals to 2 and W2 equals to 1. Now, given this x, y, and z, this table, we know that if we now try to build another table, which is like this, x, y, and z. So if I give 2 and 1, I get 5, right? If I give 3 and 2, I get how much?
3 into 2 plus 2 means 8.
Okay. If I give 5 and 7,
17. Yeah.
correct. If I give 4 and 5,
13.
right. So say this is the data that has these two columns as input. Sorry, this is input and this is output, correct?
Mhm.
I feed this whole thing to a machine. I feed the whole thing to a machine, right?
Mhm.
What the machine understands is that machine tries to find a pattern, and the pattern it gets is in the form of this, which is nothing but it is called weights identification.
So, is this nothing but the training set, the
Yes,
table?
this is the training set. This is the
Okay.
training set
Mhm.
because this is the pattern that is repeating, right? So if you
Correct.
give this, if you give this input output set to a
Mhm.
machine, then the machine will understand with a smart algorithm that is running. Machine will understand that two things. One, what is the equation? And two, what are the weights?
Equation means 2x plus y equals 0.
Yes. So the machine will understand one, the relationship between the two variables, and weights weights of that equation, right? So now if I have these two information, which is 2x plus y equals to z, and if I have the weights, which is nothing but w1 comma w2, this is equal to 2 comma 1, this becomes the knowledge of the machine. Now if I am giving this four observations or data points to the machine would be able to find the relationship of the pattern, and machine will understand this. Okay.
Mhm.
Now if I give a new number, which is say x equals to 16 and y equals to say 10, what is the output? Z equals
16
to
to 42.
42. So in order for you to calculate this, what did you need? You have to know the relationship between the two, and you need to know the weight. Correct? As
Correct.
the way that you are calculating, it is the same way that the machine is also going to calculate. This is the basic understanding of how a machine learning, it's a very rudimentary understanding of the how a machine learning system should work in order to train itself, right? If you understand this part, this is again, this is not like how all the machine learning system works, but this is a very I would say childish way to understand how the complicated a system works. Correct. So in this case, you will see that few things are very important. What is very important? The data that we are feeding to the machine, right? The number of data that we are feeding to the machine, the pattern will get more prominent. The confidence of that machine to output the pattern will be more prominent. So if I am feeding 4 data points, might be the confidence of that machine is only say 50%. If I am feeding 40 data points with this, might be the confident of that algorithm on this pattern is near to 100%, because it has more observation to validate its understanding. Correct. That's why in machine learning, there is a famous word called, this is a famous saying in machine learning parlance, garbage in is garbage out. So if you are feeding in bad data, you will get bad prediction. If you are feeding in clean data, proper data, to a machine learning system, and if you are feeding in more data, you will get more accurate result. So that's why data becomes a very critical aspect of any machine learning system. Machine learning system or any artificial intelligence system cannot work without data. So this, in order for the machine learning system to work, it is highly expected for the whole thing to train itself in some set of data. Any question till now?
So what I understood, so initially we have to train the machine with the training set,
Hmm?
and we should give as much as good data, I mean
Mhm.
good training set, and it should be more and more. Then
Mhm.
only it will be easy for the machine to identify the pattern and the weights, and a machine will have some more confidence to uh, I mean take the decision, right?
Yes. So it is easy or not easy is not the question. The question is around the accuracy. So if you are feeding in more data, the machine gets more uh, data volume to compute its own uh, prediction, and you have more confidence on that prediction, right? So how do we get confidence on that prediction is basically you compare that with the existing observation. So the one that you are feeding it, you are saying that you know that this is what this is a training set, which means this is ground truth. Like you have supplied this information to the machine. Like machine is not going to question this. Machine is going to say that okay, I'm being given this particular data to train on. Then this is the ground truth, right?
Mm.
But if you are not giving the correct data, the machine is obviously not going to give you correct
Perform.
result.
Mm.
Yeah, machine is not going to be performant, right?
Mm. Mm.
So this being said, one thing to understand very clearly is that uh, let me take another color over here. So see, when we talk about AI, AI is this very big umbrella, right? This is AI, right? In this, there is a subset of approaches which is called machine learning. So when we called what is machine learning versus AI, ML is nothing but it's a subset.
Okay.
This is a subset of artificial intelligence. Okay? Artificial intelligence, if this subset is focused on building systems, right, that learn from data, right? We just saw one example. So what does ML system do? So you should be very clear with the differences. ML learns pattern from the data, right? And it improves that pattern over time. If you train that machine with some more data, it is going to just improve, right? So
Sorry,
it makes
can you please repeat email learns?
ML just learns from the patterns of data. ML learns the patterns from data. So in this case, it is learning the pattern. If you see, it is learning the pattern. By pattern, we mean it is trying to form a equation or a relationship between the given inputs, correct?
Mhm.
To
Okay.
achieve the output, right? It is trying to form a relationship in this case um, between this and this, right? In order to get to this, correct?
Okay.
So
Mhm.
so this is the ultimate thing that we got, correct? So this is
Mm.
nothing but a relationship. How these two input columns are related in order to get to the final output, which is Z, right? But is it only this two output columns which is giving me Z? No, it is a mixture of the relationship and the weights, correct?
Mm.
So in a ML system, it is also important to understand that we are not only getting the relationship but also the weights. So when we talk about pattern means identification of the relationship and identification of the weights, right? How they can be related together with the mixture of weight and relationship in order to generate an accurate prediction. Correct? So the core idea of machine learning is that instead you are writing the rules of solving a problem. It is not a if-then else system. So you are not saying that hey machine, I'm giving you the equation which is 2x plus y equals to z. You just give me the output of 16 and 10, whether it is 42 or not. You are not saying, you are instead of saying that, what you are saying the machine is that I am giving you the data, you find the pattern, and upon discovering the pattern, see that if that pattern fits in the newer output or not, newer input or not. Did you understand?
Yes, I understood.
Okay. So here, the thing that you have to understand is that never mix these concepts of why AI ML, right? AI is the whole overarching uh, thing which we just talked about, and ML is nothing but a subset, right? Now there are certain parts of ML. Now you can also say that what are the other parts of AI, right? So in AI, here is another subset. This is called DL, right? This is another subset. Deep learning. What is the difference between artificial intelligence, artificial intelligence, deep learning, and machine learning? We will go there. Will read in very detailed. Then there is another wing called NLP. This is another subset. NLP is what? Natural language processing. Okay, that deals with mainly text data. And basically, any application of this sort, which is LLM based, ChatGPT or Claude, etc., are nothing but it is a LLM based application which lies in this subset, which is NLP system. Okay, so AI is the whole overarching thing which has lot of pockets of its own. It has an ML pocket, it has a deep learning pocket, it has a NLP pocket. These are subsets of each other. So this concept should be very clear within yourself. Do you have any question in this?
Basically, what I understood, email part is totally I understood. So the deep learning, I'm just little confused between deep learning and NLP.
Yeah. So for now, just understand that deep learning we will go into detail very shortly. But NLP is just natural language processing, which is like text
Text
based,
only.
text
Text.
based,
Okay.
and then another part it is also called this is now called Gen AI. This is also another subset, which is
Okay.
generative subset. So now GenAI can be used for LLM based application by generating a newer set. It can be used for generating a newer image. It can be used for generating a new video, new music file, right? But NLP system, it is only text based. This is only text text based systems. Okay. So this is only text-based system. But when we talk about generative AI is though it's a subset of AI, it has the capacity not to give you a prediction, but to generate a content. You need to understand the difference between giving a prediction and generation of a content. So given the input, you can ask for a binary output. All right, you can just say that whether this is going to be yes or no, or whether this is going to be what is the value of this system, what is the value of it. These are all use cases which will be on the ML side of things. We will come to the deep learning. This is basically another higher level algorithmic approach to a machine learning problem. NLP, we will always get a text-based output. But when we talk about generative AI starts on the fact that you are able to generate certain content out of your fed information. Whatever information that you are feeding, it is able to output a content, right? That content generation is not something that your email system, deep learning system that it does, right? For example, you tell ChatGPT that write me a story. It will just write you a story, right? You cannot tell a ML system, write me a story. But your ML system can give you the prediction of what will be the house price of a particular area, given that you have fed the ML system with lot of house prices and lot of features of that area. What is the population? What is the general income? What is the uh, probably the house what do you call area? Well, it will be able to give you that, but it will not be able to give you a generative prescribed fact that it is going to be like, it is not going to write you a story about it. So that's the main difference between generative AI and all the other branches of AI, if you will, right? Any questions on this understanding?
Basically, generative AI will give us the content, like you mentioned, it will give us the story or something like that.
It will
So,
generate. It has the power to generate. When I say it will generate, so basically it has the power to generate a new content. It is not just going to give you a blank output. It will not say that, okay, given that house price of 1,000 house prices, if there is a house price that is coming up, I'm going to say that this is X dollars. It is not going to say that. It is going to perhaps paint a picture. It is going to write a story. It is going to create a music or whatever. But that is also is a recursive application of an algorithm that under the hood is acting to generate that prediction, right? And it is not just that one algorithm in play, but there is a complicated layer of algorithm that is actually trying to generate the content for you, which becomes much more useful in our everyday life. Correct. So we were in the verge of artificial intelligence revolution when ML systems came in. So we were doing like simple predictions. We were doing like Amazon recommendation system, Netflix recommendation system. You visit Netflix, depending on your previous watch history, it will give you a certain level of, historical. I mean, it will give you a certain level of interested feed that you can watch. In Facebook, in Google, everywhere you have this kind of a thing, right? But when you go into generative part of it, Netflix is not generating a movie based on your text. Like you cannot say that, uh, "Hey Netflix, just generate me a movie where I'm flying in the sky." Correct? It will not do that. But that is not ML. So any system that does that, that is what is a generative part of the artificial intelligence. It will take your face. Perhaps it will. I'm just trying to draw a picture here. So it will take your face. It will make the background. It will give all the sound feature, and it will create a movie that you are flying, right? So these are certain things that the GenAI versus ML versus DL. We will go to the deep learning part a little later, but I think for our understanding part, what I wanted to understand, see, you have to start somewhere, right? So in order to start, this is the first part to start, and then you have to go to second. This probably is the third. It is also optional. Then comes generative AI, which is the very sophisticated application of AI system in general, right? It is not at first you can just go and try to understand generative AI. It is not possible. In order to understand generative AI, you need to have a solid fundamentals understanding of probability, statistics, linear algebra, calculus, and then you need to have a fine understanding of deep learning, because deep learning deals with neural networks, which is fundamental building block of many other systems, right? Then comes the generative AI. So there is a, I would say, graduated learning path. It is not that you can directly jump into generate. You can definitely do that, but then your learning will be incomplete. Okay.
yeah, understood.
Okay. So let's just get into ML. And we might not have time today to convert all the things, but I'll try to see. So in ML, there are basically two kinds of learning algorithms, right? ML algos are segregated by two different kinds. One is called, sorry, it is called supervised. Another is called unsupervised, right? So what is supervised? What is unsupervised? So the supervised algorithm, it is basically a way of learning, or you design a way of learning from labeled example. So the example that we had, that is, you are giving the input output both the pair. So let me write it down, it will make more sense. Learning from labeled examples. So what is this labeled example means? So labeled examples is nothing but it's the input output pair, right? So if you, and this is also called to some extent observation, right? So this, what we are saying here is that the class of algorithm that learns from labeled example to produce a prediction later is called supervised algorithm. Okay,
What is labeled example?
that's what input output pair, like this one.
The training set.
The training set, input and output both are given.
Okay.
Input is given X and Y, and output is also given. This is labeled. This is ground truth. This is not changing. That in some equation, 2 and 1 generates 5. It is a ground truth, right? It is a labeled example. If a system is learning from that kind of an algorithm, it is called supervised algorithm, right?
Okay.
And then there is unsupervised algorithm, which is learning from unlabeled data without any guidance. So it is learning from unlabeled data without any guidance. One example of this kind of unsupervised algorithm is basically, say, let me say that you have few balls in here. This is, say, red, this is yellow, this is green, and this is red, this is yellow, this is green, this is, say, yellow, and this is, say, again, red, right? If I am to generate an algorithm which will just bring all the red balls together, red, red, red. How many red balls? 1, 2, 3. And there are 2 green balls. Then there are 1, 2, 3 yellow balls. These are all yellow balls. And there are 2 green balls, right? If we can generate an algorithm which does this kind of thing, this is called clustering. We will go with what is the basic of clustering later. But in this case, you are not feeding the system with any kind of input and output, but you are just telling the system that given this input, which is balls of different colors, red, yellow, and green, can you group them together, right? If it groups it, so that I'm just trying to give you an example. So it tries to identify some pattern similar to the previous example. It was identifying an equation, it is identifying the pattern, it is identifying the similarities. It is identifying the similarities of characteristics, say the pixel definition of each of them. Like the red pixel is separate from the yellow pixel, that is separate from the green pixel. If it is trying to collate it together and group it together and then give you automatically the output, it is unsupervised. Are you getting it?
So just by
Learning the
understanding the
pattern,
pattern,
or
understanding the
by
pattern,
observing the pattern or the
observing the
similarities
pattern.
pattern, or it is trying to group or the similarities,
Mm-hmm.
right? Then the results are interpreted by human experts. Obviously, we can do it, and then we can use it for the downstream task, right? So, but there is a big challenge to this. The big challenge is what? The big challenge is that the algorithm does not have a way to compare its output with a ground truth. In this case, the challenge was simple. Supervised algorithm, you could have identified the output or the prediction from by comparing the output with the ground truth, which is the output of your say the equation,
Patient.
correct? Equation.
Yes.
You could have
Mm.
compared it, but in this case, so somebody who is colorblind, he will not understand the difference between all these things, but he is still a human. He might level it wrong than you and me,
Okay.
correct?
So in our unsupervised, there is no such equation or weights.
No, no, no. It's
Rather,
a, yeah,
we have
it's a
to understand the situation by seeing
by
the
observing the
observing the data.
similarities of the data,
Mm.
similarities of the data, and finding a pattern, right? And the challenge is that it can be it can be true, it can be false also, because you might find many spurious patterns, many different patterns, right? And the output just not align with the human relevant category that is expected. For example, me and you are not colorblind. We can distinguish between red, yellow, and green. But somebody who is colorblind, he might not distinguish between red and green, correct? He can
Mm.
just think that those two are the same color. But I am also a human, he is also a human, you are also a human. So what we are calling the truth, he might not label it as a truth.
Correct.
So that is the main challenge with the unsupervised algorithm, correct? So we will go with some examples, maybe with that. But before we go there, right? Let me give some overview on what are certain model types that are there for the supervised algorithm and that are there for the unsupervised algorithm. So basically, if a supervised algorithm, we understand the process, right? Again, let me write it down. So for let's go into the details of the supervised algorithm, right? So supervised algos, what is the process? The first thing is what? Can you tell me? First thing is that model is given a training data, correct? The
Mm.
model is given a training set or training data, correct?
Mm.
Second thing is the model learns the pattern and relate input to output. So the model, based on the training data, learns the
Pattern.
pattern from training data and establish a relation between input and output. Correct? Okay. And then the thing is that we are also saying that the model makes prediction, not recommendation. I forgot, it would be prediction. I think in up I wrote recommendation somewhere, but model makes prediction on some new
Interface
no, on some new data,
I don't know it.
on some new data, which is unseen, right? Unseen. So the model did not interact that kind of data before, but the model will definitely. So this thing is clear, correct?
Yes,
Yeah.
clear.
Okay. So there is a challenge to it. So the challenge of the supervised algo is this, and have again very clear understanding. So we are talking supervised algorithms, correct? So
Yes.
challenges is one. You can tell me what is the challenge, biggest challenge?
Request label data. Yeah.
This is not very easily available. Okay. Okay. So this is the biggest challenge. And then we are also saying that that the assumption is, I think this is also high level, that it follows the training and the test data set will follow the same distribution, as in like whatever the uh, training data that they are related, the testing data, when we are actually feeding the model and trying to get some output, right, on testing the data, it would follow the same distribution. That is not always the case. But in order for us to establish any supervised system, I think data cleaning slash gathering slash labeling is a very um, costly exercise. Correct? Okay. Now there are some, you are clear up till this, correct?
Yes, I'm clear.
Okay. So what are few examples of supervised, not supervised algorithm, but what are some real world example? Real world example can be, one is your spam predictor or spam detector in your email.
Okay. Oh, nice example.
Huh?
Very nice example.
Yes. So unless you mark that as a spam or somebody marks it, that is not there. And the second thing is also say house price prediction. Correct?
House price.
Yeah, house price prediction. You are giving some input to the machine learning system, and it is learning from that the variables, the certain things, and it is then giving you certain output. Correct? So these are some real world examples. Correct? Now, there are certain algorithms which are essential for our supervised machine learning system. The first is either it's called linear or logistic regression. The second is called decision trees. Let's say random forest. Third is called support vector machine. Fourth is called, it is a neural network, you can say, neural networks. But we'll go to the neural network later. But these are certain common examples of some supervised machine learning algorithms. You understood this part, correct? What are the details? We will get to that later. Are you okay?
Yeah, up to this, I'm okay. Yeah, but you are going to explain this algorithm later, right?
Later. What we do, we'll pick up and we'll very high level understand and we'll go. All right. We cannot spend more time on each of the algorithm if we
Just
if
show me the AIML box picture above. Just yeah. Okay. I'm done. Okay, thanks.
this is clear, right? Am I going too fast? Do you want me to go a little slower?
No. Yeah, the way you are uh, progressing is perfectly fine.
Okay. So then let's talk about some unsupervised algorithm. Unsupervised learnings, right? So here, what is the process? The main thing is that model is given data with no level, right? I mean, I'm not saying that this is red, this is yellow, this is green. Okay.
So you are
So
not, we are not
no,
labeling it.
no, we are not labeling. We are just giving the model this thing, right? We are just giving the model this thing, and we are expecting the model to output this, right?
Mm.
Correct. So, so here the thing is that the model identifies the pattern or the similarity or the grouping by itself. Correct. So the model identifies the pattern slash grouping by itself. Okay. Uh, then the results are interpreted, by us, by human experts later, and we say that okay, this is the right result or this is the wrong result. That is on us. Now there are some algorithms which are again. Before we go there, let's understand some of the key challenges. Right. So the challenge here, it is obviously challenge is what? The challenge is that it is difficult to evaluate. It is difficult to evaluate. Why?
Because non-labeling of data.
No ground truth.
Mm.
There is no ground truth. Okay. There is no ground truth. And then the challenge here is also that, I mean, it depends a lot on the human interpretation. So the that we get, results might not align with uh, human related categories, humans say. For example, an algorithm which is unsupervised, it can find such a pattern that, it is not, it is understood by the machine, but it is not understood by the human. So that is also a pattern, but we cannot understand that, right? So what are some examples of real world examples uh, for this kind of use cases, right? So here the real world example would be, mm, you can say, so first of all, clustering. The and the thing that I just shown you over there, this is called clustering. Given red, blue, yellow, if we can group them together, this is a clustering example. And in clustering, you can find a lot of definite ways to do that. You can cluster different users of same age group together, different users of same geographic location together, different user of similar interest together. They can be formed a real clustering, right? The second example is basically, again, the way that I was talking, I just came into mind. It is called customer segmentation.
Segmentation.
Yes. So customer segmentation is what? You divide the whole customer pool into this kind of segments where you are applying clustering methodology to your customer to identify the pattern of those customers, right? The other example is that, which is very relevant, is anomaly detection in financial transaction. So, uh, anomaly, anomaly detection in financial transaction. Have you ever got that alert from your credit card if your credit card expense certainly goes high up? So you are purchasing something for $1,000, you almost all of a sudden get a notification on your phone that, hey, is this you purchasing?
Correct. Because
That
it's
is
a not a regular one.
not a regular one, but it
All
does
of a
not have
sudden, like I purchase
yes,
high
yes.
volume of.
Yes, but you might think that it is it is not a if then else statement also. An if then else statement would mean that for anybody who is purchasing more than $1,000, I always give that alert. So somebody might every day purchase $1,000. Me and you are poor person, but somebody who is rich, he can purchase everything in $1,000 every time. That's a common transaction. So it's a pattern that the machine learning system intelligently learns, and then it says that this is not your previous behavior. This is an anomaly to your previous behavior. Hence, I'm flagging this transaction.
Hence, I'm
Flagging the transaction. Hence, I'm giving you the alert.
okay. Okay.
I mean, it is not a generic case, right?
Hmm.
You can imagine that if it is a if then else thing, it is a generic case. Somebody can just do a purchase of $1,000 and say that I'm just doing $1,000 transaction every day, but that is not it, right? It has more meaning to that. Anyways, so here are a few examples, and there are certain algorithms that we should be aware of. Um, on the unsupervised one. So the first thing is obviously it's called k-means. K-means. Second thing is called DB-scan. DB-scan, or this is actually called hierarchical clustering. Hierarchical hierarchical clustering. Third thing, I think it was called principal component analysis, PCA. Yeah, there are other examples also, but we'll go there slowly. So, okay, and I think there are like night base and other things. So, but yeah, do you understand this the whole thing between supervised and unsupervised? We only completed this part, by the way.
Yes, I understood. Yeah. But the algo part you are going to explain me later, right?
Yeah, yeah. And there is a lot of
The
understanding.
example wise, yeah,
Just
I understood. And now,
just
yeah.
hear the name of it right now. Don't go
Mhm.
into the algo. We will go into this will take some time in order for you to go into the algo.
Mhm.
Right? Is there any question that you have on the supervised or unsupervised, the example part? This is just an
So,
introduction.
yeah. So, what I understood that for unsupervised learning, there is no requirement to feed the machine with training data.
Yes, that is correct.
Only thing we need to definitely give the data to machine, but
Hmm.
it not necessarily it will be a label. It is unlabeled data. So machine itself try to understand the behavior of the data and grouping accordingly.
Hmm, hmm, hmm.
Okay. Mhm. Got it. Mhm.
Okay. So this is I think today we are closing on time, but I do want to touch on one thing, which is deep learning. Let's complete that part. Then at least we don't have to revisit this part again, right? So what is deep learning? Before we understand deep learning, I think it is fundamental for us to understand one concept. You know how the human brain works? Human brains are made up of neurons.
Mhm.
So neurons, if you remember, looked something like this. Let me try to draw from my memory, which was maybe uh, like this was one neuron, and if this is another neuron, here this is connected. So these are fundamental building block of neuron. So don't go by my diagram. This is very stupid. But there were some tentacles on each neuron, which is called axons and dendrons, if you remember. So
Mhm. Yes.
they were actually transmitting information or electric pulses through this joint, right? Between one neuron to another, they communicate, correct? So this this inspired this neural this neural architecture of human brain inspired a class of algorithm in artificial intelligence called neural network. So this is a class of algorithm. It is called neural network.
So you mean neural network is a subset of deep learning?
Yes, it's an algorithm. It is an algorithm in which is used in neural network, right? So it is basically, neural network. It has a very deep. I mean, it is a subject by itself, right? So there is something called perceptron. So what is perceptron? It is the lowest, simplest unit of a neural network. It is called perceptron. Yeah, so perceptron basically takes in multiple inputs, which is x1, x2, x3, and each input has its associated weight, which is W1, W2, W3, and perceptron computes the weight summed, which is like x1, W1, x2, W2, from its input, and it applies an activation function to determine its output. I know that this is very much going above your head, but I do not want to get into the too much detail of it. But then what I'm trying to say is that the reason I brought up this topic before telling you this, that why is this very much important, is because uh, this neural network has a way to propagate data between one layer to another, like the way that we transmit information from one neuron to other, right? So I think it is just like our brain, which have millions of neurons which communicate with each other and help us what? Recognize pattern, make decision, and learn from the experience, right? So artificial neural networks have artificial neurons, correct? That work together to recognize the pattern in data. It is just not one algorithm or one segment of work. It is multiple segment. Um, so if you imagine, for example, a company with different department, right? Each department specializes in analyzing one problem, right? Now, one problem that so how can I tell? So this is a very big company, right? It has a marketing, it has sales, it has engineering, it has HR, right? These are the department in a company.
Mhm.
So within this company, so marketing has its own ways of working, sales has its own way of working, engineering has its own way of working. Similarly, sales has an own way. Similarly, customer success is another department. And then you can also say customer support. Customer support is another department. And then you can say the other department is finance, right? Now, if you see this is the structure of a company, correct?
Mhm.
Think, can this one department just work alone? It is not possible. Marketing, in order to work, it needs some help of engineering. And engineering, some help it will need from sales. It will get some data or something from sales. It can funnel that data to marketing. Finance will need the engineering help, and finance might need the help from sales in order to up their funnel. Marketing will need the help from finance, correct? Customer support will need the help from, say, sales, right? HR will need the help from engineering. LGR will need the help from finance. So there is a lot of relation. Do you understand this?
Mm. Mm.
This is how a company works,
Correct.
correct? Similarly, so the departments pass the information to each other and collaborate to make a final decision, correct? Similarly, neural networks have layers of artificial neurons that analyze different aspects of input data and pass the finding to the next layer. Everything working together will give one output. It is not one algorithm. It is just a group of perceptron working together. It is called neural network. Just understand from a very, I mean, basic way, right? Do not
I
go into
can
the.
compare each and every department as perceptron.
Yes, 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 you can.
Okay, okay.
Individual working unit. Individual working unit.
Okay, individual working unit. Okay.
Correct. But a
Department.
decision that has to be made out of,
Combined
say,
level.
company level decision has to be made that whether we will go IPO or not, right?
Mm.
Can the decision be made just by finance department or by sales department or by engineering department? It cannot. It
Mm.
needs the input of all the things
The
together,
combined level.
to
High
company
level.
level information to get to that, right? Similarly, understand the neural network like that. Similarly, our brain also works like that. You're, it is not just one thing that is working, correct?
Mm. Based on different parameter, like we decide.
We decide, we try to
We
learn,
judge.
and
Mm.
yes, we judge, right? So what is then, where did we start? So what is the deep learning? Deep learning is the subset of machine learning, Actually, this is, I mean, I think I would have told you that subset of deep learning is a subset of AI. Basically, this is a subset of machine learning. So deep learning is a subset of machine learning. It's a way of machine learning that uses neural network in many layers to represent the data. So there are a lot of complicated data in the system that cannot generate the output just by using the algorithms that you saw above, right? It needs some very sophisticated output, right? And that's where neural networks come into play. And those neural network, it can generate some output by the use of communication between, yes, perceptrons, which communicate with each other, and they help to learn the representation of data. Okay, so there are some characteristics of deep learning. So one, I think we already talked about it. It uses artificial neural networks in many layers. So it uses neural networks in multi layers. Okay. Second is that it can automatically extract feature from raw data. So it automatically extract feature from raw data. Third is that, yes, it requires a large amount of data. And this actually helps or excels, I would say, excels processing of unstructured data. Which is nothing but images and videos. Images, videos, music, etc. Okay. So the inspiration of deep learning system or neural network, it is also loosely inspired from the structure and the function of human brain, correct? So there are in deep learning systems, right? There are certain, I would say, category we would study on that. There is a feed-forward neural network, and there is a convolutional neural network. There is a recurrent neural network, FFN, CNN, RNN, and then there are transformers. So in deep learning framework, there are basically some categories. These are feed-forward neural network. I think the second one was convolutional neural network. Third one was recurrent neural network. And fourth one was transformers. What are these things? If time permits, we'll go. But this guy over here is where your LLM starts. Large language model starts with the transformers. So I would stop today here and then we would continue next day. I'll stop the recording.